It's great to be here today. And thanks, Nora, for the introduction and the opportunity to the board to speak today. I'm going to talk to you a little bit about photopolymers and their use in additive production. I'm going to touch on some of the technologies, the OEMs that are out there, different materials, also sustainability as well in 3D printing in these materials and technologies and applications. So a little bit about our company, Tactile Material Solutions. We are a consulting firm focused on polymers and advanced materials. We're based in the Portland, Oregon area, but we have a presence in the San Francisco Bay Area as well. I'm showing here the image to the right, which is the Vancouver, Washington waterfront where we're based. We help clients address material challenges in a variety of different industries, including 3D printing, but also medical device and construction and consumer products as well. We have over 15 years of experience in materials consulting, research, in business development, and specifically building strategic partnerships, a variety of different industries, as well as materials characterization, and really presenting technical findings to a range of stakeholders in a variety of different organizations. So this includes, vice presidents, technicians, engineers, scientists, and then also attorneys and in courtroom settings as well. So as far as Tactile's work in 3D printing, we provide support related to polymer-based materials, as I mentioned. This includes kind of helping companies navigate the market. So with respect to current companies, trends, opportunities, really kind of orienting folks who are looking to get into the market or those looking to get into a different area of the market around the competitive landscape and analysis. This includes as well some of the other things we do with companies in the 3D printing space, characterization of printed materials, and then also support in technical marketing of capabilities and products. The other thing that's most recent that I'm really excited to share is we've released a report called the Tactile Report, and the first edition of which was released last month. It's available now. I'll talk to you a little bit about that later in the presentation, just highlighting it, but essentially it's a comprehensive overview of all photopolymer resin material companies that are primed and ready and doing production applications, and the 3D printers and companies that utilize this photopolymer technology. We also touch on sort of if you're a company looking to get into the space or interested about photopolymer technology, why you should consider UV cured materials for these printing applications, as well as specific case studies and examples as well. So as far as the 3D printing of photopolymers goes, there's really a large technology, it's really a large technology segment that creates the biggest revenue in the additive manufacturing market. So some folks tend to think that either plastics technology or printing of plastics, there's issues with the integrity of the parts, et cetera. And we've really moved beyond that. And I'll talk a little bit more about that in the presentation when we talk about different materials. But it's a really exciting time. I mean, photopolymers are reported to capture over half of the market for polymer materials used in 3D printing. And it's estimated that photopolymers are going to contribute about 1.7 billion in revenues in 2022. So it's really a prime category across the board of AM technologies and applications. An image of all of the different photopolymer technologies and really the technologies that utilize polymers when you're 3D printing them. So this figure that we'll go back to when we have the slides back up is really is from the Formnext 2019 conference, and it shows kind of the high-level basics of the different polymer print technologies. And in this report and in my talk, we're actually focusing on photopolymerization. And really the two main methods when you're using photopolymerization are stereolithography, where you're using a laser to cure the materials, and digital light projection or direct light processing, where you're using a projector to cure in a plane the material to make your printed parts and building parts layer by layer. The really interesting part is there's so many different companies out there that have really taken these base technologies and sort of made them their own with different enhancements. So companies that I highlight are basically a company called Azul 3D, who is focused on using their HARP, or high area rapid printing technology, printing of really large parts and really quickly. Being able to print fast is really important for production applications, because you need high throughput and you need to maximize the number of parts that you're able to print to compete with or add on to more standard manufacturing technologies. Perfect. Thanks, Nora.
Yeah, let me know when you need to go to the next slide and I'll ask
okay.
for now.
Sounds good. Thanks. Thanks for the assist. So let's see. And then another technology that's in company that I also highlight in our report is a Fortify, that's using their Flux print technology, where they're using a composite photopolymer based resin, and they're using magnetic particles to enhance the alignment of those particles, and also therefore the mechanical integrity of the printed parts. And so a lot of really cool and interesting activity going on. And if we can advance to the next slide, it's really interesting to see what folks have done. And it's not really a photopolymer presentation without at least touching on some of the very general base chemistries that are used in these types of materials. One of the really cool parts about photopolymer-based printing is that you're doing the reaction chemistry within the chamber of the print itself. So you have a lot of tunability in the types of properties and materials that you can make. So as far as that, typically there are different mechanisms of photopolymerization when it comes to 3D printing, but mostly these are free radical and cationic typically. As far as the formulation components, this is widely variable and can be tuned depending on the type of mechanical properties or thermal properties that you're going for. But this is just a general breakdown where oligomers, or the base kind of component of the formulation, is 25 to 90% or so of the formulation. You have reactive diluent monomers, also photoinitiators that sort of kick off that reaction, and then different additives and fillers for stability and other properties. It's also important to note that these printers cure at a variety of different wavelengths depending on the projector and the laser source. And an appropriate photoinitiator compound needs to be used in order to actually have these reactions go to completion. As far as the different types of categories of chemistry and resins, there's acrylates, epoxies, polyurethanes, polyolefins also that are being printed, and silicones, as well as dual cure and hybrid chemistries. And so there's likely to be even new chemistries or new hybrid chemistries that come out to really enhance the mechanical properties. But in present day, these materials are really reaching the specifications of those of injection molded materials and competing. And so another reason why the technology is really here and ready for additive production. If we go to the next slide, please. So I touched a little bit on some of the advantages, but it's really important to highlight why this technology is really useful for production. I mentioned the control and tunability that you have within the print chamber. You also have rapid curing in these photopolymerizations, and so you're able to build the parts quickly. In a method like vat polymerization or a DLP type method, you're curing an entire layer of material to build the part. Also too, you're able to use a wide variety of monomers and resin systems, which yield a vast range of mechanical properties, also thermal properties and thermal stability as well. And then a lot of these different advantages allow you to have speed and throughput, which are important for manufacturing at scale. And here on the right, I'm showing an image of a company whose name is Frozen and their DLP printer. Go ahead, next slide. So for the benefits of 3D printing, as we all know at this conference, it's well known. You have on-demand manufacturing, rapid prototyping and iteration. and the ability to print with varied designs that really aren't possible with injection molding and other manufacturing methods. And this is also particularly highlighted in the photopolymer space. Here I'm showing an example of Zortrax's LCD printer at right. And if we advance to the next slide, please. Thank you. But what's important to note, and if we're talking about production applications, 2020 was really a big year for photopolymer-based printing and 3D printing in general. As you know, we had a worldwide shelter in place in March, really a healthcare crisis and a shortage of supplies, PPE, testing kits, things like that. And so if we advance to the next slide, 3D printing really stepped up. And I love this graphic because it shows just kind of how quickly, within a matter of 8 weeks, the production of 3D printed parts to meet these supply chain shortages really came to be. And so we've got a ton of companies that are printing a variety of different parts for the applications that I mentioned. And if we go on to the next slide, I'll go into some of those. But printing face shields, also PPE and nasopharyngeal swabs for testing. And this was really noticed by the world stage. There was tons of press covering that, there's a real crises in the current status quo supply chain, the way things have been manufactured, and bringing that manufacturing on site and on demand really helped to solve a lot of these issues. And not only that, it really acted as a really great use case for all of the benefits, showcasing all the benefits for 3D printing and photopolymers in general. If we go to the next slide, you'll see that there's companies like Photocentric with their large format LCD printers were printing respiratory valves for patients, and they were actually able to print more than 40,000 of these valves each week. The picture shown at right. I mean, really incredible. You had nasopharyngeal swabs for virus testing printed by a variety of different companies. And just in my own personal experience, I've had a few different COVID tests over the last 10 months or so, all negative, thank goodness. But the first few, when I took them at Stanford, were actually Resolution Medical carbon printed swabs. So I actually had a test done by a 3D printed swab. And recently, the last one I had a couple weeks ago, unfortunately, wasn't 3D printed. They had reverted back to their old product. And when I asked why, the nurse had said that they had complaints by children for the 3D printed swabs. And so really hoping that that 3D printing can hang on and really address these different, sort of niche use cases and continue to fulfill those needs and solve those issues to become more of a mainstay in these different products, even moving forward. In addition, face shields for healthcare workers, many companies were working on these as well. And I highlight Henkel Loctite and their collaboration with Nexa 3D in that effort. If we go to the next slide, please. Additional things, showing door handles. Oh, sorry, previous slide. Super, thanks. We can stick here. So it's really oh, perfect. I think there's a little bit of a delay. Perfect, thanks, Nora. So other examples, Formlabs. They were using in the height of the pandemic 250 printers in their Ohio factory to manufacture 100,000 nasal swabs for COVID testing each day. I mean, these are high numbers that were being used for mass production, all for 3D printing, really for on-site, on-demand production. MakeLab, while they aren't using photopolymers, they also just totally pivoted from their traditional work to manufacture protective face shields for essential and frontline workers, and a variety of other service bureaus have done that as well. And then, of course, Essentium with their FDM technology, same thing. They were really able to utilize their technology to produce a quality solution at scale on a really fast timeline. So if we go ahead and advance to the next slide, You know, 3D printing of photopolymers at production scale, mass manufacturing scale has happened. It's here. And it really has come a long way. While photopolymer-based technology like SLA has been around since the 80s and 90s, those materials were really acrylate-based, and so they were brittle. They were great for prototyping, but in the present day, we've really shifted from those more prototyping materials to better materials that are really exemplifying commercial grade part quality. This is due in part to these hybrid chemistries with epoxy-based formulations. They exhibit, just as an example, less shrinkage and for moisture absorption. They also we have different companies that are using high viscosity resins to get better thermal and mechanical properties. And you can see the part at right, you know, I'm showing a dental stone mold here, but really high quality parts are a result. So it's a very exciting thing to see for photopolymer-based technology. If we go to the next slide. You see, just showing here some highlights from the Formnext 2019 conference where you know, this is really being realized in the industry where you have it heavily advertised. EnvisionTech, recently acquired by Desktop Metal, here showing, you know, production ready machines, materials, software, Carbon showing their production network, then bringing it to life. And so this is really pervasive in the industry. And if you go to a conference like Formnext or AMUG, you'll really see that this is the case. And moving beyond sort of the printing at home while those printers still exist, these technologies and materials are really being used for production applications. So if we move on to the next slide, please. So it's important to highlight the material company landscape because they're the ones who are making and developing these really awesome materials. A lot, if not most, of the big chemical companies have a significant presence in the additive space. Companies like Henkel, DSM, BASF, Huntsman, Evonik, and Sartomer all have 3D printing groups that have continued to grow over the last few years that have resins available now for these different types of applications. You also have smaller chemical companies like ChemCubed and Polyspectra who are offering resins, as well as others. Most recently, Colorado Photopolymer Solutions, acquired by Sartomer, Covestro acquiring DSM's resin business, including their 3D printing business. So you're starting to also see some consolidation as well, and merging of these different companies. But really, there's a wide range of materials that are available, from elastomers to high heats to silicones, biocompatible materials, biocompatible silicones, and also durable and high impact, all that are 3D printable photopolymers. If we go to the next slide, please. You know, a wide variety of applications are being explored and used with these materials, real world in the field applications. We're showing here example car parts, mock-ups from BMW for Mini, for Rolls-Royce in partnership with Carbon, midsoles printed by Henkel for shoes. Company BMF really focused on smaller scale printing of things like microfluidic chips, and then also silicone medical models, silicone prostheses as well, that are being all printed with photopolymers with good success so far. So it'll be exciting to see what new applications come about, what's next for these different types of materials. But in thinking about these real world applications, if we go to the next slide, it's important to highlight and think about sustainability and how this plays a role with photopolymers and 3D printing. Sustainability is a term that's thrown around a lot, and it's important to think about exactly what that means in the context of a particular industry or application. Overall, and in general, you know, with the economy, with sustainability and sustainable thinking, you're sort of moving from a linear to a circular economy. So, you know, rather than making materials, throwing them away, and that's the end of that cycle, you're switching to a circular economy where you're making them, using them, recycling them, renewing them. And when it comes to thinking about sustainability for materials, I tend to think about recyclability or biodegradability or things like that. But with regard to sustainability in 3D printing really hits and checks off a lot of boxes when it comes to achieving some of the sustainability principles that are really a mainstay in that. And this is reduced logistics, production on site, less warehousing, really the invention of a whole new supply chain. The other thing with respect to photopolymers in general, as an example, you're potentially reclaiming waste material left over in the vat for vat polymerization printing. How do you save that? How do you reuse that so that you can still print from it? And the other thing that I'd like to highlight is in 3D printing, there can be some waste initially because you're iterating on designs. You might have a defect in the part. So with the maturation of smart print technology that encourages faster and more targeted part design that you'd have to print less parts, that also is going to contribute overall to the sustainability within 3D printing. It's important to note that sustainability tends to be with intention. You have to intentionally want to incorporate that concept. I was fortunate enough to attend the Underwriters Laboratories Executive Forum on Sustainability early last year. And one of the main things they highlighted was that ignoring sustainability becomes a risk factor for companies. And so it's not just something on trend, it's important for our planet, and it's something that needs to be considered intentionally in the design of 3D printed parts. If we go to the next slide with respect to materials themselves, with sustainability, it's really easy to envision using sustainable materials for really large parts like furniture or building materials. There's a really big focus in that industry. And so, reusable materials, recyclable, biodegradable. One thing I'll say with respect to materials is it's really a tall order. We're still using well-developed chemistry to create novel materials for new and existing applications without them being sustainable. But companies like BioSelection, for example, are developing sustainable resins where there's a recyclable component in the raw materials. And so it's really exciting to think about and to kind of design materials with that intention in mind, sort of akin to designing based on availability of raw materials at scale. You have big companies who, if they're planning to have a mass-produced resin, they're making sure and selecting raw materials that are available at that scale with intention. And so doing that with sustainability also is really important to think about. So if we go to the next slide, I think it'll be my last one. Hi.
Oh, Stephanie, hi, it's Kristen. I'm back.
Oh, hey, great.
I just wanted to let you know we only have like 2 minutes. So if you want to take a look at the Q&A as well and address any of those questions in your wrap up.
Absolutely, yeah. So let me see how I get to that here. We had a little bit of technical difficulty. So right now I'm only on, I can't see.
I can go ahead and ask you. There's a, the most upvoted question is there effort into multi-material stereolithography printing tech?
Yeah, this is something that is sort of a little difficult to think about with the current technologies, because if, just from a physical standpoint, you have, say, one vat of resin where you can only have one material there, but there are companies out there who are looking to really develop multi-material printing using photopolymers, and it'll be exciting to see what they come up with in that regard. Absolutely.
Great. Let's see. Next question is, I was wondering, do you know if anyone is working on a sustainable photopolymer material?
Yeah, people are. They are. It's a challenge, as I mentioned, because basically, we're still developing materials that are using, I guess, quote unquote, non-sustainable or not sustainably forward components. And so there are folks that are working on that, doing that with intention. A lot of the big chemical companies have that also as a main focus, and how they can use renewable or recyclable materials, recyclable raw materials in their development. And it'll be really exciting to see kind of what materials come about as some of those advances occur. Good question.
Great. Well, I think that's all the time we have. So thanks, Stephanie.
Okay, thanks so much. And if you'd like to learn more, I invite you to check out the Tactile report.